This is Secondary 2 Honors, Module 7, Video number 3 on adding and subtracting rational expressions. The steps to adding and subtracting rational expressions are the same as when you add and subtract any fractions. So first what we're going to do is we're going to use the skills that we've learned previously with the rational numbers, and that's factoring the denominators. So in the previous videos we've learned how to simplify rational expressions by factoring the denominator, so we'll be doing that. Then you're going to find a common denominator, just like you do anytime you add or subtract fractions. You are going to do that by multiplying one or both fractions by some number so that they both have the same denominator. Then you add or subtract the numerators. Remember, you do not add or subtract the denominators. Keep the denominators the same, and then you're going to simplify your final answer if it's possible. And you'll use the skills that we've learned previously to do that. Okay, the first thing that we're going to talk about is, in order to find the least common denominator of rational expressions, whether it's fractions or otherwise, we're going to talk about the least common multiple. A multiple is a number that you get when you multiply by other factors. So if we take 8, multiples of 8 are 8, 16, 24, 32, 40, and so on. And multiples of 24, 24, 48, 72, and so on. And so if we're looking for the smallest one that they have in common, that would be 24. And so the least common multiple of 8 and 24 is 24. 5 and 3 is 15. Now you can get a common multiple by just multiplying the two numbers together. But sometimes that's not the least common multiple, so we want to make sure we get the least, because that will make it so that we don't have to simplify so much at the end. So for number 3, we could do 4 times 18, and we could get 72, and then m times m to the second is m to the third, but that's not the least common multiple, so we can do better than that. So what we can do is we can look at multiples of 4, so 4, 8, 12, 16, 20, 24, 28, 32, 36, and 18 is 18, 36. Well, there's one right there, so we're going to stop as soon as we get a common multiple. So 36 would be the least as far as the coefficient goes. So we'll say 36. And then if we look at m, and then m to the second power, they have the least common multiple that they're going to get. We're going to have to multiply both of those. So we're going to have to say m to the second power, because m to the second power can't go into anything smaller than m to the second power. So this would be our least common multiple. Number 4, if you remember, this x plus 2 is one factor, and this is one factor. So this is really a lot like number 2. We just got two factors that are completely different, and so the least common multiple is just going to be the product of those. And so you can either write it like that, or you could multiply it out. Usually we don't really need to do that for any reason though, and get a trinomial. Okay, and then number 5, again, this is just like number 2. We've got one factor there and one factor here, so the least common multiple is going to be the product of those. So you can just write it like this. You can multiply it out if you want to. Sometimes it serves a purpose, but most often it doesn't need to be done. So you could write it like that. So now let's put that into practice with rational expressions. Okay, so number 6, find the sum or difference. So the first thing that we need to do is, when we add or subtract fractions, we have to have a common denominator. So from your previous experience with fractions, you know that your common denominator is going to need to be 12. So what we're going to do is we're going to think to ourselves, what do I need to multiply 3 by in order to make it into a 12? Well, I have to multiply it by a 4, so I have to do the same thing to the top. So really I'm just multiplying by 1. On this fraction on the right, I'm going to multiply by 3 over 3 to turn that denominator into 12. So when I do that, I'm going to have 4 times x plus 7 plus 3 times x plus 2 all over 12. And so I can simplify that by saying 4x plus 28 plus 3x plus 6 over 12. And that's going to be 7x plus 34 over 12. And that would be my simplified rational expression, that is the sum of the two fractions that I have. Okay, number 7, now if we look at our denominators, we have a little more complicated, so we have 3x and 2x. So if I look at my multiples of 3x and 2x, you could just go 6x squared, But the x squared is a little excessive. We don't quite need that because x can just go into x, and so we can just say 6x. That would be our least common denominator. And so what I'm going to do is I'm going to say, well, I need this to be multiplied by a 2, so the top will be multiplied by a 2 as well. This will need to be multiplied by a 3 to turn it into 6x, and so I'm going to do the same thing to the top. So 2 times 3x plus 4, and then I'm going to subtract, and then the 3 times 2x plus 1. Watch your negative sign there, because you don't want to lose track of what it does. So now I'm going to distribute, so I'm going to have 6x plus 8. Now this 3 is going to be a negative, so negative 3 times 2x and negative 3 times 1 all over 6x. Now my 6x minus 6x, that's going to cancel out, and I'll be left with 5 over 6x. And so that's my answer. There's nothing I can do to simplify it. There's no common factors, so I'm finished. Okay, number 8. This one, we have actually 3 factors that are going to go into our denominator. And I can tell that because if I look at this one right here, if I factor that, that factors to be x plus 2 times x minus 2. You want to use your factoring skills to find out what all the factors are because you don't want to do more than what you have to. This right here, that factors to be 3 times x minus 2. So if I look, they already have something in common, and so that's good. But then they also need to have a 3 and they need to have an x plus 2. So my new denominator will be 3 times x plus 2 times x minus 2. So then the next question is, what do I have to multiply each of these fractions by to make them have the right denominator? So this one's already got the x plus 2 and the x minus 2. It just needs a 3. So I'm just going to multiply there. This one already has the 3 and it has the x minus 2, so it just needs an x plus 2. Okay, so my denominator, I've already taken care of that when I write this down here. So on the top I'm going to have 3x minus 6 by distributing, plus, and then I'm going to have 2x plus 4. And so that's going to give me 3x and 2x is 5x, and negative 6 plus 4 is negative 2, and I'm going to have that over 3 times x plus 2 times x minus 2, and so my answer is that fraction. I cannot simplify it anymore, and I can tell that because my numerator can't be simplified. It can't be factored, and so there's nothing that would cancel with anything down below. Okay, on number 9, I want you to pause the video and I want you to make an attempt to do this problem and simplify it on your own, and then press play and come back and see if you did it right. Okay, the least common denominator, we've got a factor of x plus 8, and then I need to factor this right here. That's going to factor to be x plus 8 and x minus 2. So my common denominator will have the factors x plus 8 times x minus 2. Now this one right here already has the x plus 8, so I just need the x minus 2. Don't make the mistake of thinking, oh, it already has an x minus 2. It doesn't on the bottom, so we have to multiply that. This one already has everything we need, so I don't have to do anything to change that one. So right here I'm going to multiply that, so using the FOIL method, so it's going to be x squared minus 4x plus 4 when I get all simplified. And then I've got this minus sign in the middle, and so it's going to be subtract the entire thing here, and you've got to be really careful with that because that's a mistake a lot of people would make, because they would just do minus x plus minus 2. So it's actually minus x minus 2. So x squared minus 4x plus 4 minus x plus 2, and so I'm going to need to simplify that. So that's going to be x squared minus 5x plus 6 over x plus 8 times x minus 2. Now at this point it's very tempting to say, oh, okay, that's just like all the other ones we did and now I'm done. But actually, if you examine it just a little closer, this numerator can actually be factored, and you have x minus 2 times x plus 3, whoops, x minus 3, over x plus 8 times x minus 2. And so you can actually cancel two of those factors and you're left with x minus 3 over x plus 8. And so that's actually the simplified version of that answer. Okay, number 10. Again, go ahead and pause and try this problem and then come back and see if you did it right. Okay, this right here has factors of x plus 3 times x minus 3. This has a factor of x minus 3, so my new denominator will be x plus 3 times x minus 3. This one has everything we need, so 4 is good. Minus. And then this one right here needs an x plus 3. So minus 6 times x plus 3. So when I distribute that 6, I'm going to make sure I remember that that's a negative 6. So it's going to be negative 6x minus 14 over x plus 3 times x minus 3. I want to double check and make sure that I can't simplify it anymore. The numerator could be factored, but not into anything that's useful. So I don't need to worry about it, and that would be my answer. Okay, number 11, go ahead and pause. Try this one. Come back and check your answer. Okay, so my common denominator is 2x minus 1 times x minus 1. The fraction on the left needs an x minus 1, so when I multiply that together using the FOIL method, I'm going to get x squared minus 1. Don't forget that we have this minus sign in the middle, so I'm going to need to really pay attention to that. So I'm going to just deal with the factors over here. So I'm going to do 4x squared minus 1, and then I'll worry about distributing my negative. So that's going to be x squared minus 1 minus 4x squared plus 1 over 2x minus 1 times x minus 1. So my 1's are going to cancel on the top. I'm going to have x squared minus 4x squared, so that'll be negative 3x squared over 2x minus 1 times x minus 1. And so that's my answer. Alright, number 12. This one is a combination of a complex fraction, so we've got some division. We've also got something that we need to simplify down on the bottom here. So I'm going to write this out as 1 divided by, and then I'm going to worry about what's inside here. So 1 minus 1 over t. So I'm going to focus on, I need a common denominator for this that's in the parentheses, and then I'll come back to this part of it in just a minute. So the 1 minus t, my common denominator would be t, and so I'm going to multiply by t over t. So t over t is 1, so that makes sense. So I'm going to have t minus 1 over t. So that's what I'm dividing 1 by. And so when I do that, I'm going to do 1 multiplied by the reciprocal, like I learned in the last lesson. And so 1 times anything is the same number. That's the identity, and there's our answer. Alright, number 13, this is the last one on this video. And so there are 3 fractions we're adding together. So pause it, see if you can get it, and then come back and see if you get it right. Okay, my common denominator is going to be x minus y times x plus y. This first fraction, this already has the x minus y, so I just need the x plus y. This fraction has everything. X minus y times x plus y is x squared minus y squared, so I won't need to change anything about the numerator there. And then this one on the right needs an x minus y. So x times x plus y. And then I'm going to watch this negative sign right there really closely. So I'm going to put the minus x squared plus y squared. And then I'm going to have plus xy minus y squared. So now to simplify that, I'm going to look for like terms that I can combine. And so I'm going to have x squared, and then right there is a minus x squared. And then I'm going to have plus xy. And then I'm going to have minus, well, maybe I'll put minus y squared here. Got this plus xy right there as well. And then minus y squared. So that simplifies. The x squares cancel out. I'm going to have 2xy minus 2y squared over x plus y times x minus y. Now before you think, oh, okay, that's good, let's make sure that we cannot simplify it. On the top we can actually factor that. I can factor out a 2 and a y, and I'm left with x minus y. So when that's over x plus y times x minus y, we can see really quickly that we can cancel factors. I'm left with 2y over x plus y. Okay, that's the end of this video, so you can complete the worksheet section that has to do with video number 3.